Hai, Assalamualaikum warahmatullahi wabarakatuh. My name is Mama Muqri bin Sazil Akhwin. My ID student FM922400009 and I am from class 9C. Today I want to presentation about my job sheet C. Okay, first of all, I want to give my lab procedure. First, set up the transformer according to the delta to star connection. And ensure all connections are correct and safe using the provided schematic. And third, apply a balanced three-phase load self-impedance on all phase. And number four, measure and record voltage. And number five, phase to phase. Number six, phase to ground. And number seven, change to an unbalanced load. Number X, measure and record new voltage reading. Number 9, uh, r- write, write the circuit for the star to delta configuration. And number 10, repeat the test using a balanced load. And 11, last, compare all result and analyze system performance. And lastly, follow all safety procedure throughout the experiment. In here, I choose a material first three-phase transformer, and second resistive load, balanced and unbalanced, and number third multimeter and voltmeter, and number four connection wires, and number five three-phase AC power supply, and lastly circuit diagram delta star and star delta connection. Okay, Delta star connection. To begin with, we conduct an experiment involving two delta to star transformer connection, which is a common method used in electrical power distribution system to transfer high voltage from the transmission lines to lower voltage suitable for consumer usage. This type of connection is essential in stepping down to the voltage while maintaining a stable and secure power flow. During the experiment, our focus was to observe how the system behaves under balance and unbalanced load condition and how the voltage and current reading differ in each case. In the first part of the experiment, we apply a balanced load to the delta star connection. This means that each of use a three-phase carrier and equal loads following is to examine to the system under ideal condition. We carry out two type measurement. The first was face-to-face measurement, where we measure to the voltage between each pair of line. And then second was face to ground measurement, where we measure to the voltage between each individual line and the ground or neutral point. This measurement allow us to analyze the voltage stability and distribution across the transformer terminal in a balanced system. The result option from this setup show that the voltage across all the three phases were nearly identical, indicating a well-balanced system with proper voltage transformation from delta to star. The reading confirm that when the load is balanced, the transformer operates efficiently, and the voltage across each phase remains within acceptable tolerance level. Despite of the experiment emphasizes the importance of load balance uh, in, in ensuring optimal transformer performance and minimize system loss. So this our result for the balance load. For a balance load, delta star. In the next press to the expression, we introduce an balance load into the delta to star configuration. Unlike the previous setup, the loads are connected to each base where intentionally makes equal to simulate real-world condition where perfect loads balancing is rarely achievable, especially in residential or commercial distribution system. This scenario us to understand how the transformer reacts when the power demand is not evenly distributed across all three phases. For result analysis, as expected, the results show clear indication of voltage and current imbalance. The phase voltage were no longer equal, and there were a slight variation that indicates the stress placed on the transformer due to the unequal loads. This experiment was particularly useful in demonstrating the constitution unbalanced loading, such as increased neutral current, voltage distortion, and reduced efficiency. It highlighted the importance of load management and system design in real-life electrical networks. And lastly, star to delta connection. After completing the delta star connection figuration test, we proceed to investigate the star to delta transformer connection. So this type of connection is commonly used in generator system or in industrial application where a step up voltage transformation is required. The the star to delta connection is known for its ability to handle higher starting current and provide better fault tolerance, especially in three phase motor system. Our aim in this section was to observe how this configuration perform under a balanced load condition. We connected a balanced load across to the star to delta transformer setup, ensuring that each phase carry an equal amount of power. This allows us to observe the ideal operation of the transformer, where the voltage transformation should occur smoothly and the power distribution across the three phases should remain stable. We measure the output voltage and monitor the waveform quality to ensure to the system behave as expected under optimal loading condition. The result from this part of the experiment confirm the proper function of the star to delta connection. The voltage were stable and consistent across all phases, indicating that the transformer was operating effectively under balanced conditions. This reinforces the theoretical knowledge and that we had previously learned in class and provided us with practical confirmation that balanced loading leads to efficient and reliable transformer performance. So I went to my conclusion, my our reflection. First, the experiment improved my understanding of delta to star and star to delta transformer behaviors. And second, I observed how loads type balance versus unbalanced impact voltage and system operation performance. And third, hands-on experience help connect theory to real-life application. And number four, one challenge faced was ensuring all connection were correct and safe to avoid short circuit. And lastly, I want to say overall this lab was valuable for deepening my knowledge of the first transformer system. So that are so that are for me. Thank you.